Happy 2025, everybody. I'm Jared Longfox, one of the hosts and organizers of this AIAA Space Resources webinar series. We have a really cool talk today from NASA's Armstrong Spaceflight Research Center, and specifically the Flight Opportunities Program. I've had the opportunity to actually do some Flight Opportunities projects, and they're an absolute blast and really useful for developing space technologies in general, let alone the emerging space resource technologies market. So with that, I can hand it off to our speakers, Macarena and Greg, Chloe, and with that, I'll turn off my video and you guys can start sharing. Turn on your video as you see fit. But I'm here if you guys need anything. Thank you for the talk.
Thanks, Jared. So just a quick mic check. We're still good?
Yep, I can hear and see you. And the slides.
Excellent. Okay, would you progress to slide 1? Hey, look, there's us. So yeah, as Jared mentioned, so well, Macarena and I, Greg Peters, will be speaking with you. I'm the acting program manager for Flight Opportunities. Macarena is our technologist with our tech team in Flight Opportunities. And I believe Nettie was feeling under the weather today, so we won't get Nettie today. And we can progress to the next one.
I think Greg dropped out for a sec. We've been having some connection issues. Greg, you're back?
I'm back. I'm going to kill my video.
Fair enough.
All right. All right. Did you guys already go through this slide?
Not yet.
Okay. All right. Well, hey, I will just start off by saying that I really like the space resources topic. It's probably it's one of the funner ones. My background's in geology and geotech, similar to yours actually, Jared. Although not quite as in depth as you. I'm a little shallower. But before I was involved in the planetary science part of it, I worked in the mining industry. And there's this popular saying, among people who make their living in mining is that if it's not grown, it has to be mined. So, meaning every single material that we make or, into the things that make our lives better, it was either grown or it was pumped or it was dug out of the ground here on Earth. So I really can't help but imagine the significance of that first bit of off-world ore, whether it's a mineral or a metal, that's really going to be one of those moments that represents, I believe it will represent a phase shift, kind of in civilization, to be honest, not to be too melodramatic, but because it's going to be the moment that we've plugged into this unimaginable abundance. It's things don't actually have to get dug out of Earth in order for us to make the things that we use in our lives. So, okay, yeah, enough of that. So Flight Opportunities. You see our mission statement here. Well, I'll start off just by saying that they're just reiterating that we are out of the Space Technology or instituted out of the Space Technology Mission Directorate, which means that we're very serious about getting technologies developed. So STMD, that's kind of the corner of NASA where they care a lot about that. And because of the flight test culture, we are based out of Armstrong Flight Research Center. And as you see in the mission statement there, and I'm always fond of saying that if you know anything about mission statements, you know that like no single word is in there by accident. So we're serious about every single word of that. We're serious about moving fast. So that's one of the tenets of the program. We move really fast. And the reason that we can move fast is because we exclusively use commercial flight providers. And they're really overarching two objectives, both the technology development and also this being able to foster the commercial space industry, right? It's there's parallels to the the aviation industry of the last century, was there was a lot of experimentation going on, a lot of things happening in parallel, folks doing experiments, folks failing a lot. So there was a lot of risk tolerance. There are a lot of parallels here. And if we want to make it to that next step, we want to become spacefaring people, then we're going to have to have a vibrant commercial space industry. And next slide. Okay, here we go. So this is a slide that shows the type of tests, or the types of test platforms that we work with. We have your rocket-powered vehicles, and these are vehicles that travel beyond the Kármán line. Your Blue Origins, your Virgin Galactics, those types of vehicles. They offer, minutes, multiple minutes of microgravity. They're also good observational platforms for instruments. And you have high altitude balloons, which offer kind of that low pressure. These are, we steer away from saying near space, but these are lower pressures at these higher altitudes, which give you an opportunity to test like the thermal systems. These are relevant thermal environments. They're also great observational platforms. And I always like to remind people that, at about 100,000 feet, your pressure altitude is about the same as Mars. So, being a Mars guy, I have to say it by law. Then you have your parabolic flights. Parabolic flights are, these are unique in that you can fly relatively large payloads, and you get multiple periods of either microgravity, Martian gravity, or lunar gravity. So you get to iterate a lot. And sometimes folks are iterating in between parabolas. Jared may be able to say some things about that, actually. And then we have the vertical takeoff and vertical landing vehicles. These, it's kind of amazing at how many things that we've tested. And that vehicle that's pictured there is Zodiac, which was previously Maston, now is Astrobotic. And that thing just stays busy with all sorts of research, including hazard detection systems, plume surface interaction studies, sample acquisition. In fact, we have a sample acquisition that we'll show later in this deck. All right. And then we have orbital platforms hosting what we call hosted orbital, which is relatively new to us. We've got a few slides that I'm going to gloss over. Next slide, please. So, like I mentioned, this is relatively new to us. We were previously just a suborbital program. We're bringing in hosted orbital here, and the kind of the key tenets here is that we don't fly vehicles themselves as part of this. We really just host on flight providers' vehicles. Our payloads have to stay attached. In other words, there's no free flyers as part of the rules of operating here. And the payload service provider or the vehicle provider, they take care of interfacing. They'll work with flight opportunities. They'll work with the PIs. They take care of the interfacing. They take care of the mission management and the launch. And so that offloads the PI quite a bit. There's quite a bit of potential test options, and those will grow as commercial capabilities expand. Each of these providers, in order to qualify to become an IDIQ provider for us, they have to have successfully flown a 2U, 2 kilogram. But a 2U is I'm using air quotes. You can't see me, but I'm using air quotes. So it's not CubeSats, but about the volume of 2U, 2 kilogram payload. It has to have at least orbited the Earth once, and then they qualify to apply to on-ramp onto our IDIQ. And because of this IDIQ, our offerings decrease time. So in other words, we get things from the bench to the spacecraft a lot faster, or at least that's the hope, right? That because we have these IDIQ contracts, we have standard services and non-standard services. If you bring a payload to us and it has interfaces that are standard, it's small, it's low power, and it fits right in, we can probably get you in as a standard service. We already have price lists for that, and that goes pretty efficiently through NASA procurement. And because of the way that these are written, non-standard services are actually not a huge issue as well. It's really just a bit of a back and forth between the PI, flight opportunities, and procurement. And we can get these we get these out competed. We get providers that come back and say, yeah, we can do that, and it'll cost you this extra bit, and then we can usually get it on contract pretty quickly. Next slide, please. So in this particular case, like this really shows the advantage of working with commercial providers. It's really the services really vary widely. So if you were only working with one, or if you just had, if you were just working with NASA's spacecraft or DoD spacecraft, the options would be pretty limited. But because we're working with multiple commercial service providers, the services are really everything from CubeSats to possibly hosting on a like a Dragon launch vehicle. So I think that was the point of this slide. Yeah, the upper rocket upper stages is another interesting one too. So perhaps even larger payloads. Next slide, please. And here we're just hammering the nail even further, right? So this is the simplest path, we think, for research to take. We work with all different different types of research types, not just research, technology development, research, and instruments. And so we think that there's opportunities here to actually do missions as well as technology development. And because we have frequent on-ramp opportunities, this is just expected to grow. Next slide, please. So because this is a space resources group, we thought it would be fun to try to figure out, well, what are the types of technologies that we've actually run through our program that space resources folks might care about. And because I'm a geotech guy, when you're a hammer, everything looks like a nail, right? So the first thing that comes to mind is really sample acquisition and the ability to do prospecting and geotechnical measurements. So just a very slight few, a handful of these are the Honeybee Robotics Planet Vac, which is also one of the technologies on the Dragonfly Blue Ghost mission that's going to launch tomorrow. So we're really proud of that. So that's a technology that was tested through our program. Dual RASP sampling system, which is you can imagine both Planet Vac and Dual RASP are the types of technologies that are tag type sample acquisition. In other words, I don't necessarily need to have a lot of gravity. I can deploy these to an asteroid or a comet, and I don't need a lot of reaction force. I just need to get down, touch, grab a sample, and even if I bounce off of the asteroid or the comet, I've gotten a sample. And then Sparta is a unique one. And Jared, you want to say some stuff about Sparta? I know you worked on this one.
Yeah, sure. I am indeed a co-investigator on the Sparta project with JPL. Sparta is an all-in-one toolkit to characterize planetary regoliths, bearing strength, shear strength, thermal properties, and some electrical properties as well, including detecting the presence of volatiles such as water ice down to about half a weight percent. It's a really cool, really unique project, again, like Greg has mentioned. I'm a geomechanics, geotech, physical properties person, so that's kind of my jam. It's a really unique instrument, and we have flown it on zero-G parabolic flights in the past. We hope to do so again this coming summer or late spring. And we're also going to be launching Sparta's vane shear tester and dielectric spectroscopy probe on an upcoming Blue Origin suborbital flight. So stay tuned for some of the data and analysis from that. It's going to be really cool.
Thanks for that. Yeah. It is pretty interesting. And by the way, maybe you got connections. Maybe you can get us a better picture, because I know that Sparta has progressed quite a bit.
I'll talk to Bob.
Thanks, man. Appreciate it. It's good to have connections. Next slide, please. Oh yeah. So not only are these sample acquisition. Look, I believe that space resources kind of like it crosses the gamut of almost all types of technologies, including comms and all the other ones. But we thought that the actual hazard detection type technologies is also really important. In order to get to the surface, you have to have some sort of hazard detection type instruments on board. We're highlighting, we did a what's called a TechLeap prize, which is something that Macarena is going to talk to you a bit about. But our second iteration of TechLeap was to find low cost technologies for hazard detection. So these are sensors that can give you hazard detection, that are low swap C, so lower cost, lower size. And the idea behind that is you're going to send a lot of small spacecraft places, and you're going to send less expensive spacecraft, then your LiDAR system probably shouldn't take up the lion's share of the payload bay, and it shouldn't take up the lion's share of the cost. We ended up running this challenge. If you're going to do this as an experiment, you would probably want a solution that was a LiDAR, like a pure LiDAR. You'd probably want a pure optical solution, and you'd probably want something that was a bit of a hybrid. And it just turned out that the three teams that won, we got exactly that. We got a pure LiDAR solution, the University of South Florida, that took small LiDAR units and multiple heads, and was able to integrate those to do mapping. The Bronco Space Club at Cal Poly Pomona had a hybrid solution where they were using structured light, which I always describe to people as a QR code that it projects onto the surface and does some machine learning calculations to determine the topography, along with some LiDAR. And then Falcon Exodynamics, a small company, had their Little Owl system, which was a single camera that used movement to get stereo vision to bring up a 3D, or to develop a 3D map. And also what came out of that is the Astrobotics Lunar Surface Proving Ground. So we tested all three of these systems from 500 meters down to 200 meters over this the Lunar Surface Proving Ground, which remains out at the Mojave Spaceport, 100 meters by 100 meters of hardscaped lunar terrain that has very close spectral qualities to the moon. So we're super proud of that one. And next slide, please. And okay, so I had mentioned that we do technology development, or that's one of the areas that we're looking at. And then there's instruments, and then there's fundamental research, primarily because we're a space technology mission directorate program. When we use our own funding, so we have a bucket of dollars to put towards flight testing. We'd rather people think of us as your one-stop shop to come in. We have the subject matter expertise, we have the relationship and the contracts with these flight providers. So people who have their own dollars can come to us, and we can contract directly with these flight providers. We're happy to do that. You get our services for free. You use our contracts for free. But when it comes to our own bucket of money, it generally goes to technology development, and we use a few funding vehicles to get that done. One of them has historically been tech flights. We generally run tech flights, been kind of on a yearly cadence. We did not run it this year. We won't be running it this year. We are running another instance of TechLeap. Macarena is going to talk to you about that in a second. And then the other thing is our flights of opportunity. Now, these are technologies that have previously been developed to some stage with NASA, has some sort of relationship with NASA, and then we can actually work with STMD to get those flights funded through our Flights of Opportunity program. And I see that we do have a QR code here as well. If you want to hit that, it'll take you to TechPort. And I believe we have, being as we're talking about funding vehicles, and let's talk a bit more about TechLeap, and I'll hand it over to Macarena.
Thanks, Greg. First things first, can everybody hear me?
I can.
Good. Okay. And I'm not going to tempt fate and go on camera because I can already tell there was quite the delay from when I hit the next slide button to when Greg was seeing them. So we'll not tempt fate. So a little bit about TechLeap. So you've already heard Greg talk about it. And just a minute, there we go. So an overview on TechLeap. You probably keep hearing the word fast, rapid. So Flight Opportunities is all about kind of making the pace a little faster of technology development, that is. And TechLeap is one of our tools that allows us to do that. It allows us to go a little faster than we would with a standard grant, and to give cash prizes to technologies that are of interest to NASA that can fill our needs. And so we hope to kind of speed up the pace of development. And the idea of TechLeap is it's a prize. It's not a grant. So you get a cash prize if your application gets selected. And on top of the cash prize, you get an opportunity for a flight test. So we've done this a number of times now. You can see 4 on the slide. And it's open to more types of groups than what you would normally see in a grant. In grant, you're usually talking about more group universities and people who have a track record and stuff like that. This is, you could be in your garage and getting things started, and you're eligible to apply to TechLeap. So this is our 4th that I'm going to talk about. So we've had 3 before it, and you can see on the slide, they have been very specific. They are looking, as Greg talked to you about the nighttime precision landing, they have a very specific problem that we're trying to solve, and we're essentially putting a call out to anyone with great ideas on how to solve that problem. This one is not specific because it's kind of trying to replace the tech flights this time around. So in our case, we're looking for very varied ideas. Anybody who can solve a shortfall, and yes, there are limits to that, and I'll go into that in a little bit. But it's not a very specific problem. It's far more diverse what we're looking for. So let's see, next thing. So if I got your creative juices going and you're like, hey, I think I want to apply, a little bit more of information about that. The prizes, should you get a prize, it's worth up to $500,000, and I'll go into why it says up to in a couple of slides. And you get an opportunity for a flight test. Like I said, the flight test is not, you don't have to pay for the flight test out of those $500,000. That's in addition. In this case, we are giving up to 9, we're selecting up to 9 winners. And the idea, as has always been the Flight Opportunities idea, is our goal is to advance technologies through flight testing. So in this case, we're looking for any of our potential contracted flight providers, so suborbital, hosted orbital, parabolic flights, and there'll be a list a few slides later. And we're looking for good ideas, but of course, we're more interested in good ideas that can benefit from a flight test. So things that are well suited to flight testing is what we're looking for. And as far as the topic of your idea, is it's really anything that, well, it's not anything. We're looking for things that are useful to solve the future exploration needs of NASA. And there's a wide range of STMD technology shortfalls that are part of this call. And so if you can fit into one of those, we're looking to please give us your ideas. And also another one is the NASA's commercially enabled rapid space science initiative, which I'll talk a little bit about at the end. So who can apply? Anyone who's a U.S. citizen or permanent resident is eligible. I shouldn't say anyone. Anyone who's over 18 and a U.S. citizen or permanent resident is eligible. Organizations that are U.S. organizations, so primarily based out of the U.S., and any team that is led by someone who is a U.S. citizen or a permanent resident and is in an organization that counts. So if you're a foreign person and not a permanent resident, how can you participate? And the answer is you still can participate. If you're a foreign citizen, but you're also an employee of a U.S. organization and you live in the U.S., you can apply to this. You can also apply to this if you're a full-time student at a U.S. university and you're living in the U.S. Or if you're an owner of a company, but that company is more than 50% owned by by a U.S. organization, therefore it's considered a U.S. company, you are eligible to apply. How about government employees, contractors, and FFRDCs? And in this case, the quick answer is they're not really eligible, but a government employee or an FFRDC employee can apply if they do not rely on resources available to them from their employment. So, so that's a fine print thing. And if you're interested, I encourage you to read the rules and to reach out to us with questions. And with contractors, similarly, they can participate if the technology they propose is not something that's already federally funded. Oh, let's see. So timeline. As I said, this challenge opened recently. It opened December 10th, so a little over a month ago. There will be a Q&A on February 12th, but there have also already been a couple of outreach events that were recorded, and you can find those recordings on our websites, and maybe Chloe's could put some of those links in the chat for others. And the registration deadline is March 4th at 5 p.m. Eastern, with another Q&A shortly after the registration deadline and the actual submission deadline on March 20th at 5 p.m. So if you want to register or you want to get information, there's a QR code in the bottom. We also wrote down the website information. If you fall into those gray lines of like, am I really eligible? It's not obvious. We encourage you to look at our frequently asked questions. And if it's not there, reach out to us with a question. And there's the email, questions@nasatechleap.org. So after submission deadline, what happens? Well, we hope to select winners by July 2025. And here's the explanation of the up to $500,000. Winners will get a $200,000 cash prize, at which point they begin what we call payload build round 1, and that goes from July to November 2025. And if you successfully complete that, you get another $200,000. At which point you move on, you progress to payload build round 2, which should run from December to April. And when you successfully complete that, you get the final $100,000, and we start working with you for a flight test. We are targeting a flight test in summer 2026. And there's a note down there that the vehicle is to be determined by NASA. So we encourage, if you're applying to this, to really concentrate on what do I need out of a flight test? How much microgravity time? What kind of environments do I need? Rather than I'm going to fly on flight provider XYZ, because that may not be what you get. Having said that, here are a list of all the potential flight providers that are part of the IDIQ. As you can see, they range from suborbital rocket-powered vehicles, high-altitude balloons, parabolic flight, and orbital platforms. Even though I just said that the actual flight provider is to be determined by NASA, I encourage you to go to that website listed below where there's more information of each of the flight providers and understand what the different capabilities of the different flight providers are, so that when you apply, you're not applying for something that's just not even possible, and you stay within the capabilities. You understand what can and cannot be done with a flight test. So let's see, anything else on this? No. So finally, I've mentioned more than once that this is a very broad range of STMD shortfalls. So there is a website down below there where you can get more information about all the STMD shortfalls, and that we selected a subset of those that we believe are well suited for flight tests. And the ones we selected, we are on. I hope I can't see the chat, so I hope Chloe's putting them in there. There is a website that has the information of all the specific technology shortfalls that are part of this call. So we encourage you to go there and look through that and see if you have some ideas that can fill some of those needs. The other one that I mentioned is the Cirrus program, which is, of course, I can't see the notes. Commercially enabled rapid space science initiative or something like that. The idea behind this program, it's run by SMD, Science Mission Director, and the idea is to increase the pace of science in space. So if you think about our current pace conundrum, we come up with an idea, we propose it, we get money, we fly the idea, we wait for our sample return, and then we have to analyze and prepare our samples and figure out what went right, what went wrong. And now we're back to square one, applying for the next time around. And so as you can imagine, this is a years long process. And so anything that allows you to do in situ analysis or in situ sample prep and quickens this pace is of great interest to SMD. And that's what Cirrus is looking for, is anything that gives you sample analysis capabilities or sample preparation capabilities. I think that's it. With that, I'm going to hand it back over to Greg.
Thanks, Macarena. So this is the portion where I'll be hemming and hawing a lot, but we do encourage people to reach out to us, and we have a particularly strong outreach arm in flight opportunities, and so we have opportunities to learn as much as you want to learn about flight opportunities through our community of practice webinars, which happen once a month. We have a newsletter. Please sign up for our newsletter, because it's always packed full of good stuff, or at least we think so anyway. And what else is in here? What's the next one? Oh, yeah. Not only do we have a great outreach, we also try to learn from. We try to document the things that we have learned. So we do have a lessons learned library. We have multiple meetings with flight providers, with people who have flown through our program. We try to learn all of these best practices, and we try to get those documented so that we can keep those, and those libraries are actually made public for you all as well. Next slide. And there we go. This looks like the last slide here. So I do want to thank everybody for attending this. We do like talking about flight opportunities. I personally think it is one of the best, if not the best, programs that NASA offers. I think I love we are not with human safety, but certainly with mission assurance. We are risk tolerant. We understand that experiments are going to fail, vehicles are going to fail. We're going to learn every single time from that. So it's an incredibly exciting program, and hopefully we can find a way to work with y'all as well. And I think that is it in terms of slides. And I don't know if there are any questions. I'm not seeing any questions in the chat, but maybe there.
Yeah, I
I'm gonna
forgot to
stop
mention that
sharing.
at the beginning. People, feel free to put Q&A in the, or well, Q's, I guess, in the Q&A at the bottom. Chloe and I are working on going through and posting a bunch of useful links in the chat as well. I hope you guys have seen those come up. So hold on. Yeah, if you guys have any
I
questions, I
have
mean,
I have a question for
yeah,
you.
yes.
While folks are formulating the questions, if they have any at all, what can you tell us a bit about the space resources webinars? Where did that spur out of? What is the objective? And give us a little background and where you're headed.
Yeah, absolutely. And good question. So the AIAA Space Resources webinar series is put on by the AIAA Space Resources Technical Committee. We're a group within AIAA Space and Missiles Group, which is why my name on here is Space and Missiles Group and not Jared. But we're specifically hosted by the Education and Outreach Subcommittee. Joe Kenrick, the other host and lead of this webinar effort, we are co-chairs of that Education and Outreach Subcommittee. In general, the goal of this is to host webinars on topics that are of interest both to uh, seasoned professionals in the space sector, or even K through 12 students interested in space and how we go about exploring space and the state of the art in space resources. It's really just to generate awareness of the space resources cause. A lot of times there can be a little bit of negativity against the concept of space resources, and we're hoping to dispel some of those negative preconceptions that people have. And I will say we don't just limit this strictly to space resources. Space exploration in general is an open field, and space technology development is open to us because it all plays together in space resources. You can't have space resources without space exploration, and the other way around as well. So that's kind of where we're going with this, and we try to host, yes, individual researchers to give talks, but also programs and people like you guys who run great programs to give researchers opportunities and just increase the awareness of the resources available to people looking to do space resources work. Does that answer your question, Greg?
Yeah. Thanks for the background on that.
No problem. All right, I'm going to paste another link for community of practice webinars. Thank you, Chloe, for pasting all these in the chat as well. I don't think you're able to send them to the entire audience, but I can.
Yes, thank you for passing those along.
Yeah, no problem. And lessons learned library coming through. And if anyone needs these links afterwards, I think I get a transcript of this chat, or I can just ask Greg, Macarena, and Chloe if they have these resources afterwards. I do see one in the Q&A, so hold on. I'm doing a few things at once here. Lessons learned library. Okay. I had no idea how much documentation and resources you guys had. All these links are amazing for anyone looking to do a flight opportunities project. I will certainly be referencing them. Okay, now on to an audience member's actual Q&A. Karis Kosmos asks, in case some de-risking is required before an actual test flight, like a hypervelocity facility, Is there an interface for this to inquire?
We may need a little bit more. I can say that our our budget. So if we're talking about things that we can pay for, we cannot pay for technology development. What we and nor can we pay for facilities development. The only thing that our budget can be used for are either paying for flights on commercial vehicles or payload development, which is different than technology development. So I don't know if that actually answers the question, but if not, we'll need a little bit more clarification on that question.
No problem. Karis, if that answers your question, I realize you don't have a chat, so you can punch in the Q&A if you need to clarify or anything like that. But while you type that, I have a question. When someone submits a proposal to the to one of your guys' programs or applies to something, what is the number one most common, I don't want to say damaging factor, but what is the number one pitfall to avoid? And I realize that's an extremely open-ended and case-dependent question.
Can I toss that to you, Macarena? So Macarena is a technologist on our tech team. Probably the best situated to answer this.
Yeah, can you rephrase the question? What is the number one pitfall to avoid when applying or when getting ready for flight?
When applying
Flying.
is what I asked, but I guess I'll ask the second part in flight after.
Well, not very straightforward for either of those. This is almost going to sound a little cheeky, but gosh, the number one pitfall is be clear what you're saying. It's amazing how many times you read something and you're not really sure what it is they're proposing. If nothing else, have a friend read it, have a colleague read it, have someone go through and tell you if they understand, or are they getting the same idea that you're actually trying to get across. So be clear is the big one. As far as what's the biggest pitfall in flight, in this one, I'm kind of going to sidestep in that it kind of depends on the flight provider, and that's where our lessons learned is immense. I mean, it's some of the obvious things, like for parabolic flight, it's never put all your eggs in one basket. Don't think you're going to get it all done in one flight, because it is a very distracting environment. And the first flight is almost in some ways a throwaway, because you're just getting used to the environment. If you haven't done it before, you're getting used to the environment. It's loud, it's fast, everything's happening faster than so practice for one. I mean, I've seen people like tape out the area and go through the motions, and that really helps. But the biggest pitfall, I think, to answer what you really asked, the biggest pitfall is going to depend on the flight and on the flight provider. What kind of flight are you doing?
That makes sense. And no, excellent answer. Thank you guys. And Chloe also and I punched in the chat, which you should all be able to see, the section on preparing proposals in the lessons learned library. Like I said, I don't know that I've seen a NASA program or series of programs have this good of documentation. So kudos to you guys at Flight Opportunities.
Not everybody has a Chloe, so
well done, Chloe.
Thank you.
In the Q&A, Parra said there is someone can answer. I'm going to say we should probably take that offline. And Karis, if you contact me or Greg or Macarena or Chloe, we can probably discuss this more via email or something. Perfect. So I'm gonna give a minute for others to punch in the Q&A. But in the meantime, have any or all of you done any flights or flight projects, parabolic, suborbital, etc.?
Go ahead, Macarena. I know you have.
Sure. Yes, we did, and very much the in the spirit of flight opportunities. This is long before I got involved with flight opportunities. It was very much a fly fix fly. It was fluids never do what you expect them to do in microgravity, and we had sample preparation technology that we were developing, and we wanted to test different parts of it to see if the fluids would go where we expected them to do, and what were the issues. And the interesting thing, what we learned was a lot of the things were as expected, but one that we just totally did not expect happened, and we had to redesign so that we could avoid it. We kind of did a quick cheat. We had to, you couldn't push a syringe plunger down too quickly, or else the liquids did not go where you wanted them to go. And so we purposefully made it, instead of a syringe plunger, we we made it a screw that the astronaut had to turn to force them to go slowly, and that worked because we flew it on ISS successfully a few months later.
Cool. Yeah, and that's exactly the kind of thing, the progression that you can do through flight opportunities, from lab testing to parabolic or suborbital flight, and then on to a launched vehicle, even to the ISS. That's really cool. So I thought I saw, let's see. Nothing in the Q&A. Greg, I
And
saw
did
you on
you
mute.
you flew with Sparta as well, right? You were actually on a parabolic flight.
Coincidentally, I was on a parabolic flight back in late 2021. And it was for a project here at UCF, Strata 2P under PI, Dr. Addie Dove, shout out. Um, and it was actually really similar to Sparta, testing regolith properties in low gravity. And uh I mean, not that I'm asked, I've only done one parabolic flight campaign to date, more coming soon, but it was really, really cool. And the number one recommendation I have is, even if you're not a type of person who gets motion sick, you may want to look into anti-nausea medication. I'm forgetting the name right now, but there's patches you can get that work. You put them on the night before flight and take them off right after. They work very well. You wake up feeling a little weird, but it keeps you from getting sick on the flight. I'm not a motion sick person, but I'm still glad I had it, because those flights can be a little disorienting. Um, the but yeah, no, if you can ever do one, folks, they're super, super, super cool. One of the coolest things I've ever done, if not the coolest thing, which is not saying a lot, but it's definitely up there. And in the link, oh, whoops, I just set hit something I didn't mean to. Um, if you want to learn more about the program, I'm copying a message from Chloe. I can't copy and paste from the chat into the chat, it turns out, so I'm hand typing everything. You can reach out at NASA-flight opportunities at mail.nasa.gov. Okay, there's an email address in the chat that you all can use to reach out with questions. I'm trying to, I keep wanting to ask just general questions about like resources and guides, and Chloe did too good of a job at providing them. So I'll have to go over that myself, but if nobody else has any questions, speakers, is there anything else you'd like to add to this? Any parting thoughts or comments?
Thanks, Jared, for inviting us. Actually, this has been a lot of fun, and I really hope that this group, gets some wheels under it, and does great things in the future.
Well, thank you very much, Greg. Yeah, it's been great to have you. I think this is one of my I'll show my bias here, but this is one of my favorite programs, and I'm really glad we could get some representatives from Flight Opportunities on. This is going to be a highly referenced talk, I think, by this community. With that, if nobody has anything,
well, you know what? I do have a question.
Yes.
Is there a way that we it would be a good idea, or it would be neat. I will say that, certainly not required. It would just be cool and neat if we knew, if you let us know if this talk gets referenced. And we're always about our impact, and so it's like, are we shooting in the right direction in the right places? And so that would be a good bit of data.
Yeah, no, absolutely. What I usually do is once I get the YouTube video uploaded, I'll send you guys a link so you can actually share it. If you guys want and are able and can send me a PDF of the slides, I'll upload those on a publicly available AIAA page. And throughout the year, I tend to send our speakers updates on how many views the YouTube videos get. So you'll have that to track as well.
Sounds good.
I don't have a direct way to see if there's anything formally referenced, though. But if I see it, I will let you guys know, rest assured.
Well, if it's on YouTube, I guess we can pay attention on our own.
Well, fair enough, but I don't. I go through and do my own tracking on it, so it's kind of I can let you know conveniently enough.
Sounds good.
Okay, with that, I think we can call it. Thank you guys so much. Thank you everyone for attending. Stay tuned in early February for the announcement of February speaker. Have a great day. I hope your 2025s are going well and continue to go well. See you, everyone.
Thanks, Jared. Thanks, everybody.
Bye-bye.
Bye.
Thank you.